Hey everyone, today we're going to talk about proportional and non-proportional rates. Today we're going to learn to identify proportional relationships and to use equivalent ratios. So before we look at our vocabulary, it helps to kind of look at an example. So let's look at this. It says Mrs. Cochran is planning a year-end pizza party for her students. Ace Pizza offers free delivery and charges $8 per medium pizza. We're going to complete the table to determine the cost for different numbers of pizzas ordered. So if I look at this table, we know it's $8 for one pizza. If I order two pizzas, that's going to be $16. And if I order three pizzas, that's going to be $24. And if I order four pizzas, that's going to be $32. And if I order 5 pizzas, that's going to be $40. Please complete the chart. Now, for each number of pizzas, we're going to fill in the boxes to write the relationship of the cost and the number of pizzas as a ratio in simplest form. So we know 8 to 1 is equal to 8. 16 to 2 is equal to 8 over 1. 24 to 3 is also equal to 8 over 1. And then 32 for 4 pizzas is also equal to 8 over 1 if I simplify. Remember, just divide the top by the bottom. And then 40 pizzas divided by 5 gives me 8 over 1. So, what do we notice about the simplified ratios? Okay, we notice that the ratios are all equal. Each ratio is equal to 8. So we're going to write that down. Let me grab my pen again. The ratios are equal. Each ratio is equal to 8. Boy, my handwriting looks pretty bad. All right, so let's look at the next bit of information. Make sure you copy this information into your notes. We know that two quantities are proportional if they have a constant ratio or unit rate. For relationships in which the ratio is not constant, the two quantities are non-proportional. Well, wow, that's a lot of confusing information. So let's look back at our pizza example. In the pizza example, the cost of an order is proportional to the number of pizzas ordered because 8 over 1 is the same as 16 over 2, which is the same as 24 over 3, or 32 over 4, or 40 over 5. Remember, all of them were equal to 8, so $8 per pizza. So all of these ratios above are equivalent ratios because they all have the same value. Make sure you copy this all in your notes. So now let's take a look at example number 1. It says Andrew earns $18 per hour for mowing lawns. Is the amount of money he earns proportional to the number of hours he spends mowing the lawn? And explain. So the first thing we're going to do is we're either going to create or look at the chart that's already been created for us. And we find the amount of money he earns working a different number of hours. So we know 18 times 1 is 18. If he works 2 hours, we take 18 times 2 and get 36. And if he works 3 hours, 18 times 3 and we get 54. And 4 hours, 18 times 4, and he gets $72. The next thing is for each number of hours worked, we write the relationship of the amount he earned and hour as a ratio in simplest form. So notice here we've got the amount earned to the number of hours, 18 over 1, which is equal to 18, 32 over 2, which is equal to 18, 54 over 3, which is equal to 18, and 72 over 4, which is also equal to 18. So what do we notice? All of the ratios between the two quantities can be simplified to 18. So our answer would be the amount of money he earns is proportional to the number of hours he spends mowing. And that's so because they all equal 18. So let's look at our next example. Example number 2. It says Uptown Tickets charges $7 per baseball game ticket plus a $3 processing fee per order. Is the cost of an order proportional to the number of tickets ordered? So if we look at this, we know one ticket costs $7 plus a $3 processing fee. 7 plus 3 is 10. 2 tickets would be 7 times 2, which is 14, plus the $3 processing fee. So that's 17. 3 tickets would be 3 times 7, which is 21, plus the $3 processing fee, making that $24. And 4 tickets would be 7 times 4, which is 28, plus the $3 processing fee, which is $3, so that makes that $31. So what we're going to do is we're going to compare. So we're going to do the cost of the order to the tickets ordered. So let's write that down. Cost to tickets ordered. So our first one is 10 over 1, or 10. Our second one is 17 over 2, or remember 17 divided by 2 is 8.5. Our third one, I'm going to come down here, is 24 to 3, or 8. And our fourth one is 31 to 4, or 7.75. All I did was divide those fractions. So now, if you look at these, they are all different. So the answer to this one is, since the ratios of the two quantities are not the same, the cost of an order is not proportional. So this one would be not proportional. Let's look at our third example. It says you can use the recipe shown to make a fruit punch. Is the amount of sugar used proportional to the amount of mix used? Explain. Can you guys hear my dog in the background? She's running around like crazy. Anyway, so back to our problems. So if we look at our chart, we can do our cups of sugar, to our envelopes of mix. So in our first one, we have 1/2 over 1. And if we divide, just like we did last week, We do 1/2 divided by 1, or 1/2 times 1 over 1, and that becomes 0.5. Then our next one is 1 to 2, or 1/2, which is also 0.5. And then our next one is 1 and 1/2 to 3 envelopes. So if I divide, that becomes 0.5. And our last one is 2 to 4, or 0.5. Now there is a mistake here in this chart, I noticed. This should be 1 and 1/2 here. So notice that all of these are the same. So that means that all of the ratios between the two quantities can be simplified to 0.5, right? So the amount of mix used is proportional. So we can write the amount of mix is proportional to the amount of sugar. Let's look at our fourth example. It says, the tables shown represent the number of pages Martin and Gabriel read over time. Which situation represents a proportional relationship between the time spent reading and the number of pages read? Explain. So let's look at Martin first. We have 2 to 5, 4 to 10, and 6 to 15. So if I look at Martin first, I'm just going to put an M for Martin. So we have 2 to 5, 4 to 10, which I can reduce by dividing by 2 to 2 to 5. And then we have 6 to 15, which I can reduce by dividing by 3, 2 to 5. So we know that one is proportional, right? So let's look at Gabriel. I'm going to change colors here, so we'll go Gabe. We have 3 to 5, 4 to 10, which we know is the same as 2 to 5. And then we have 7 to 15. Okay, so we notice we do not have 3 that are the same. So all of the ratios between Martin's quantities are 2 to 5. So Martin's reading rate represents a proportional relationship. So what we can do, and I'm going to switch colors again, and I'm going to go, we can say the answer to this question is all of the ratios between Martin's reading rate are proportional. Now, finally, let's take a look at example 5. It says Anna walks 6 miles per day. Is the number of miles she walks proportional to the number of days she walks? So let's fill in this chart. If she walks 6 miles in one day, in 2 days she walks 12 miles because 6 times 2 is 12. And in 3 days she walks 18 miles because 6 times 3 is 18. And in 4 days she walks 6 times 4, which is 24. So now let's compare. We have 6 to 1, 12 to 2, which is equal to 6 to 1, 18 to 3, divide by 3, I get 6 to 1, and 24 to 4, which is also equal to 6 to 1 because I divide by 4. So in this case, Anna's rate is proportional. Let's look at a last example. It says, a cleaning service charges $45 for the first hour and $30 for each additional hour. Is the fee proportional to the number of hours worked? Make a table of values to explain your reasoning. Well, we know that for 1 hour worked, it's $45 for the first hour, right? So that's the first hour, so we're going to say that's 45. Now the second one, we know that it's $45 for the first hour and then $30 for another hour. So 45 plus 30 is 75. Then for the third one, it's going to be $45 for the first hour and then 30 for the second and 30 for the third. So 45 plus 30 plus 30 is going to be 105. And then for the fourth one, we know it's $45 for the first hour, 30 for the second, 30 for the third, and 30 for the fourth, or 45 plus 90, which is 135. So now we know the first one is 45 to 1. Which is equal to 45. The second one is 75 to 2. I just divide, and I get 37.5 or 37.5. The third one is 105 to 3. I divide, and I get, let's see, let me grab my calculator. 105 divide by 3, I get 35. And the fourth one is 135 to 4. So if I divide that, I get 33.75. Now notice, none of these are the same. So that means the ratio of fee for 1 hour of work is 45 to 1, and the ratio for 2 is 37.5. So the fee is not proportional. So here are your on your own problems. Try them and come back to class with any questions that you have. See you tomorrow.